Hello guys, welcome back to the channel. Today we are going to see flow over a flat plate. Let us create the flat plate and see the boundary layer formation over it. So first we are going to open the ANSYS workbench. From there we are going to select fluid flow fluent. Now we are going to generate geometry. So if you see the file, we have to create a rectangular flat plate and the parameters are length and height given as 1 meter and 0.5 meter. So first let us do that. Right click on the geometry and open new design modular geometry. Now after the geometry opens, first we are going to units and setting the units to meters. It's default meters, you can leave it into meters only. Then select the XY plane and select this icon, that is look at face icon. Now you're going to go to the sketching option, take a rectangle, locate the center and draw the rectangle as shown. I'm going to show it to you now, magnified view. Now you're going to go to the dimensions and take the vertical, select these two lines and its height is given as 0.5 meters. So I'm taking the height 0.5 and enter. Next, we have to see the length. Length is given as 1 meter. Select this surface and select this surface. And the height will be 1 meter. So this is our rectangle. Go to modeling. The sketch is ready. We are going to create surface from sketches. So go to concept and click on surface from sketches. Click sketch 1 and apply and generate. So a flat plate will be ready. As you can see here, the length is 1 meter and the height is 0.5 meters. Next, we are going to add the name selections for this, for which click on the edge select and click on this line and right click. Go to name selections and apply it as inlet. Enter. Generate. Again repeat it for the other edge. Name selection, outlet. Enter. Generate. Now click on the both surfaces up and below the edges. I'm going to give these both walls. You can give it as symmetry or walls. It's your wish. Name selections and wall. Generate. So you have your three boundary conditions: inlet, outlet and walls. So this is the geometry required. See, the boundaries are inlet, outlet and wall. Now our next step is going to meshing. I'm going to close this design modular geometry. And now I'm going to open the mesh file, that is go to mesh and right click and edit. 1 meter, so I'm taking about 10 divisions. First we'll check with 10. We can make it more precise. I will take 100 divisions, then make it hard, and bias type, bias factor I'm taking 10. Now you have to zoom in and check it's reversed. Then I'm going to check for the other side. This is correct. See, if you observe here, you have to have it from big to small in ascending order. If you see here, edge sizing ascending from bottom to top. Okay, so I'm going to apply a reverse bias for this side. Apply. Now if you go through this, you will see this is big and it's getting smaller as you approach the top. Okay, both are same. We'll check it once. See, look, that is done. Go to mesh, insert sizing. Now again select the edge sizing option, select both walls, the up and bottom one, and apply. And here also I am going with number of divisions and giving the same number of divisions I gave there. You can give extra. Okay, I'll give 200 because the height is exactly half. Okay, so after giving the divisions, it's hard mesh and that's it. Nothing you have to add here. Go. Now I'm going to insert face meshing. I'm going to select this face and apply and generate. So you can see uh, and I'm sorry for the first edge sizing. I'm going to edit it. I'm going to select this one because we want small one at the bottom. Yeah, this should be the correct one. Yes. Now if you generate, see, this is what we are looking exactly. Okay, we need this type of mesh. Now the next step is setup. I'm exiting this and right click on the mesh and click update. And double precision you keep it on, and processors I'm going to select 4 and start. So this is your inlet and this is your outlet. Keep it a pressure based model in general and go to models. It's SST K omega and I'm keeping the energy on. Then coming to the materials, I'm going to select the fluid and air and keeping everything constant. What is given I'm keeping that intact. Then create and change and close. And I'm going to the boundary conditions here, and at the inlet it's velocity inlet, and I'm going to give the boundary condition at velocity inlet as 1 meter per second in x direction. So velocity, magnitude, components, and change it to 1 meter. And here gauge pressure, I'm keeping it 0. Apply, close. And outlet, pressure outlet, gauge pressure 0. Apply, close. And then I'm not going to touch anything. I'm just going to check the reference values. Check if the pressure is 0 and velocity is 1. If it is good, then we are good to go. Otherwise, you can change here. Then methods, I'm going with the simple and keeping everything as second order. Then go to the monitors, first report definitions. I'm going to give it a force report of drag and lift. It's not necessary, but I want to just see how drag is there. Okay, then lift. Now go to the monitors and residual and 1e to the power 6. Copy this and paste it to everywhere. Click OK. Then go to initialization, hybrid initialization, and initialize. Initialization is done. Now you have to run the calculation. Go to run calculation, and here I'm going to change the number of iterations. I'm going to take 500. You can take, if you have more time, you can take more. You have to see if the solution is converged or not. So for that I'm taking 500 number of iterations. Data file quantities, select everything. Okay. Now calculate. We'll check the scale residual ones. So the solution is converging. The solution is converged. If you want, you can do more iterations, or else just you can close this and go to the results section. So before going that, I'm going to go to file, interpolate, and I'm going to write this data. Give some file name. Flat plate. Okay. Close. No. Click on the solution and update it. Solution is updated. You can click on the results and edit it. Console access so that the face will be on. And I'm going to give this counters, location, symmetry 1, and I'm going to give the velocity counters. Number of counters, I'm going to make 101. Because we have taken it as wall, we can see boundary layer at the top and also at the bottom, but our main focus is at the bottom. You can clearly see how the boundary layer is running here. To plot the velocity vectors, location on symmetry 1, symbol, arrowhead 3D, apply. So I'm going to zoom it out. Turning off the streamlines. I'm going to reduce the size. You can see the boundary layer here clearly. This is our flat plate. To this flat plate, we have given the counters. Because we have taken both sides as walls, we can see the boundary layer on the top and also on the bottom. And then velocity vectors, if we add, we can clearly visualize the boundary layers here. The velocity gradient, we can see how the gradient is forming. So that is the tutorial for today. Thank you. Please subscribe our channel.